So today we're going to talk about differentials and solid axles versus independent suspension axles, kind of what the uses are, and I'm going to break down mechanically what's kind of going on in here without opening this. I've got Lego Technics, which I've been a huge fan of since I was a young kid. Use them forever, and I have a massive collection, so I figured it'd be a great way to exemplify what's going on in here since they have all of those parts. But long and short of this is I'm going to be doing a fluid swap in my Jeep Dana 44 rear diff. These are fairly easy because they have a drain and a fill. I believe I had water get into mine because I do need to replace the seals, which I will be doing the next roundabout. But right now, what I need to do is just pull out the low plug and let that drain out. You can see my fluid is nasty. And then this little plug up here will allow more air to come through and it can pour a little bit quicker. So I'll set that there and let that drain out while we kind of go over what these differentials do. If you're doing this job, by the way, be very mindful of the oil itself. It is the stinkiest oil I've ever known. Gear oil is nasty. These Dana 44s, check your manual. Every vehicle is different for what your vehicle is and what your applications are. These take, because it's a locker and it's the Dana 44, it takes the 80W90, and it does need an additive for limited slip. So if your oils don't come with that already in it, you have to add that. I would make sure you have rubber gloves. Again, this stuff stinks. If you get it on your skin, you will not eat food from your hands for a good 12 hours. It's disgusting. But let it drain out, put the low plug back in, and then fill until it kind of seeps over the top of the fill hole. It's the quickest and easiest maintenance you can do, and you should do it fairly regularly. Gear oil does take a lot of wear and tear, and it's something that a lot of people overlook. And I think it's a lot to do with people are just afraid of differentials, kind of like opening up a transmission. So I'm going to try and do my best at a quick, easy example of differentials and how they work. Like I said, I'm a Technic fanatic. This is a vehicle that I built to hold. I have a gimbal that my phone can attach to, so I can drive my gimbal around. I can adjust it. I can rotate it. This thing is pretty cool. I've got some older videos about that. This one I used to harass the dogs with, but I removed the springs to help this one because it has a lot of upper weight. I brought some extra gears and stuff to kind of show what's happening here. So a differential essentially is a very simple mechanical device. And what it does is has a series of gears that transfer energy in a way that is to differentiate from side to side, essentially. This would be, in Lego world, a carrier. And this outer gear here is the ring, which meshes with the pinion gear. And on a vehicle like the Jeep, those are commonly inside your differential, and they face, see my pinions leaking there. This is your rear drive shaft. As it comes into the rear differential, that connection where it goes through there is where the pinion meshes with the ring gear. Those two gears together, the input side from the Jeep, the small gear, the pinion, and the large gear, the ratio between those two gears is your gear ratio. Often you'll see 373s or 410s, and what that's saying is it's one rotation of the input shaft, or output shaft rather, is equivalent to the input having to rotate 4.1 times or 3.7 times or so on. So it's basically just telling you how much it's geared down for torque at the end point. So what that looks like in Lego world, again, is just a different version of that same thing. Here's your ring gear, here's your pinion gear. This would be your drive shaft as it comes in, and those are your two output shafts. This would have your tire, and that would have a tire. So I've made an example with an exposed diff over here so you can see that. Why this is important is when you're driving your vehicle, both wheels are spinning traditionally at the same speed if you're traveling in a straight line. But when you start to take a corner, that changes. And what's happening is the energy that is needed to supply, say for instance, this vehicle is going straight forward, and then it takes a right-hand turn. The inner circle that this tire is going to make is a smaller in diameter circle
than this tire. So this tire is going to need to spin more rapidly than this tire. And that has to all be done mechanically with one of these. And what that does is, if you're driving straight, the internal gears, often referred to as spider gears, are meshed and are not spinning out of synchronous with the carrier. They're just going with it. But as soon as you start to take a corner, those gears start to allow the transfer of the energy to go from side to side. You can see it rotating in there. And you can actually hold the input shaft and still rotate the two in opposition, which is an open differential. Those things are important because an open differential can cause you to get stuck if you've ever driven somewhere where there's low friction. So for instance, snow, like in the Northeast, and you've had one tire of your car go off the side of the road, and then the tire that has traction isn't spinning, and you're like, what the heck? One tire is just not getting it. Well, as soon as you make one tire easier to spin, that's the tire that will spin, because the way differentials allow transfer of energy is to the side of least resistance. That's super important, and the reason that they make locking differentials. These little Lego ones actually have lockers so that you can actually put a locker in these ones. These are a little bit more complicated and they're a little bit harder to understand, but we'll get to that eventually. So basically, the differential just allows you to take corners and also allows for the wheels to spin at different speeds, essentially. But that allowing speed difference is a positive thing and a negative thing. When you get into what I believe back in the 70s, the EPA mandated that all gas stations allow for free airing up of your tires, because the gas mileage increase that is caused if you have two tires that are exactly the same inflation versus two that are not. So these are two different sizes, and instead of the carrier spinning everything synchronously, there's a little bit of an off step because one side is smaller. So it's actually spinning faster than this side, and that causes a lot more use of power input to achieve that offset in the differential. So that means obviously keep your tires inflated and make sure that's a huge priority, especially in huge vehicles that can lose a lot of diameter on a tire by losing some of that. The other part of that would be that obviously your wear on the tires is worse if you don't inflate them properly, but your gas mileage is going to suffer even worse. Then beyond the differential itself, there are different ways that the axle from the actual differential going out to the wheel actually transfers that energy. So when an input is being changed in direction, so you have a U-joint, which is a very common piece in this kind of world, these often go bad, and they do it most often when they're engaged. So this is engaged in an angle, and it now has to transfer through that centerpiece. Much like a differential, once it's facing adversity, it has to change how it outputs. If this is a straight line, nothing's happening. They're both rotating together and nothing is bumping. So what happens is, when I'm spinning it in a straight line, there's no resistance. But when I tip it a little bit, there's a lot more resistance, and it causes me to have to turn more torque to get that same output. In a solid axle, like you find on proper off-road vehicles, if you look at military usage and most real extreme off-road, they usually go for solid axles. Independent front suspension does have its place, but usually when it's at the grade of effectiveness for off-road, it's much bigger and much clunkier, I would say. And you also lose a little bit of articulation in most cases. So this is my example of a solid axle. And you can see the axle shafts drive straight from this little differential out to here, the hub, and both sides want to spin at the same speed. And this is not a locked differential. Then you have the same concept where both go out to the side, but in this case, these have U-joints. There's one at the end and one here. If you're ever going between 2 points and you have to use a U-joint, you usually have to use 2 or a double cardan in cases where they're not aligned. I'll go into that again in another video of how that concept works and why. But the biggest trick is when you lower one side of an independent front suspension outside of the other, whichever side has the least resistance through the U-joints now is the tire that spins. So in applications like sand, you would want to be using lockers if you have independent front suspension, because they will always be at different heights rather than on the roadway. This is important where I live, where we have a lot of sand and off-roading. So a lot of times you'll see washboard marks, and that's usually from the hopping effect of a tire getting traction and losing it. But that being said, the effectiveness of a solid axle is usually greater than that of independent front suspension. The biggest advantage of independent suspension is ride quality. If you have independent front suspension, your ride is probably 10 times more smooth and more akin to a car rather than a truck. So those are the big kind of differences between those two. And the reason that they're different is because of the flexibility and how it bends. This also, in the way of its differential, is usually fixed, and these are allowed to move. These, which are usually called wishbones, those allow the wheel hub to move up and down like that. Whereas on a solid axle, it's usually on a 3 or 4 link suspension, and what that does is allows it to tilt left to right like this. So it's a little bit different in the way that it makes contact, where these will actually usually make flat contact up and down, whereas on a solid, you'll tilt away. So the angle of the tire will be kind of offset to your traction point. That's about as far depth as I want to go into these without getting a little bit more technical. So I just wanted to kind of go over that while I let this drain out. And as you can see, in about the 10 minutes it took me to explain that, it's almost completely drained. I'll wipe it clean, and then I will refill it with new fluid by re-cleaning off the bottom of this. There'll be some metal filings on there, which is pretty normal. You don't want a lot of them, but it's pretty normal to have them wear. I'll reinsert the bottom screw, snug it tight, and then I will fill back in fluid until it starts to kind of pour over the end here, and then I'll recap it, and that will be done. So if you're out there using your Jeep on a regular basis, I would highly advise buying some cheap but nice quality differential fluid and doing your differential service. I hope you enjoyed, and if you have any questions about how differentials work or any other questions in regard to mechanical engineering, let me know. I'm going to do a bunch more videos with Lego explanations because I think they make it much easier to understand things. So hope you enjoyed. I hope you like and subscribe, and I'll see you next time.